Welcome back. Our final speaker today is Professor Ashley Hall. Professor Hall is Professor of Design Innovation in the School of Design at the Royal College of Art in London and a visiting professor at the Central Academy of Fine Arts in Beijing. Professor Hall researches in design innovation, methods ranging from innovation strategy to design thinking, design for safety, experimental design, design pedagogy, globalization design, and cultural transfer. He has developed and led commercial academic partnerships in a range of different industrial sectors from transportation to communications. Let's welcome Professor Ashley Hall.
Hi there.
Hi, good morning.
Thank you very much for the introduction, Professor Wang. I'll just share my screen now and start my talk.
Thank you.
Okay, good. So hope everybody can see this.
Yes, we can.
So first of all, thank you very much for inviting me here today to give a talk. It's a real pleasure to give a talk in Hong Kong PolyU and for the Business of Design Week. So my talk's called The Business of AI Design Education, Researching and Teaching AI. And I'd like to address some of these questions that we were given for the talk. What would be the potential development of AI in 5 to 10 years to come? Would AI likely be an ally or more an enemy for human beings? Should AI be perceived as objects or subjects in design? For example, a discussion of AI for design or design for AI, perhaps? What might be the role of designers in an AI-driven world? And hence, what would that impact be on design practice and design education? So I'm hoping to show you some examples of that today as we go through. So I'd first like to start talking about complex machines. These are obviously this is the Saturn V rocket from the 1960s on the left-hand side. And on the right-hand side is the Enigma machine, which is used to break codes in the Second World War. So this is an era when we started to develop very complex machines that needed large amounts of human intelligence in order to understand how they worked, to design them, build them, and use them successfully. Particularly if we look at things like the first digital camera, we think it took about 150 human beings' minds to understand how the first digital camera worked. And then if we look at the space shuttle, that took about 10,000 human beings' minds. So a huge amount of human ingenuity, intelligence, and capability just to understand this one machine or collection of machines, how it actually worked. And of course, this was back in the 1980s. So significant amounts of human intelligence are needed. And one of the big questions we have now is with artificial intelligence is, will there ever be enough minds? Can we ever put enough people into a room or into a kind of single collaborative space where we can actually understand all the intricacies of this technology, how it can be used, how it can be designed, and how it might impact our lives now and in the future? And so these are some of the questions that come out of these observations about humans and complex machines and AI in particular. How can we research and design for technologies beyond human understanding? And how can we even research, design AI when we don't even know the key questions? Certainly my point of view, I think a lot of the researchers that I work with is that we're still looking at that early phase of AI design research and trying to work out what those fundamental questions are and actually how that starts to shape our design research environments. And some of the research that we're doing in the School of Design, postgraduate research, we're starting to explore these questions. So we're focusing on designing through, with, and for artificial intelligence. We're investigating how AI needs new form of design practice, new design methods, new ways of developing projects, new ways of developing outcomes, findings, assessments. We're looking at exploring trust, cybernetics, participatory design, ethics, languages, design probes, anthropocentrization, all in design AI. We're also collaborating with a range of other disciplines to do this, and we're very much looking towards having a sort of delivering tangible outputs. So this isn't purely theoretical research. We're looking to design, build, test, generate projects which can really explore this new set of design challenges, and from that start to draw out some of those key AI research questions. So here are some examples of some of the work that we're doing, postgraduate research. This is Yulia Inescu, and Yulia's looking at the anthropology of Things, and this is a Microsoft-funded PhD looking at how we can improve designing for AI engagement through new visualization feedback loops, and also how we can develop models of anthropocentrization. So by that we mean human behaviors and human attributes. So when humans work with complex machines, we kind of give them names. We start to imagine they have human personalities, human traits. And this is a very interesting research angle on artificial intelligence to start to understand how we can build those anthropocentrizations, how we can start to see human characteristics inside AI systems, how we can leverage that in terms of design to improve communication, and also how we can build visual feedback loops of conversations with AIs for designers. Second example, this is Gustav Borgenfalk, and he's looking at governance and ethics of services, service design as persuasive systems. So he's looking at how we can use languages of cybernetics, and he's applied this to projects that are tackling cyberbullying, online cyberbullying, and he's working with the service designers and the platform developers and using a language of cybernetics, so understanding feedback loops, black boxes, requisite variety, governors, and so on to help build the language of cybernetics in persuasive systems. Fernando Galdon's looking at how we can design trust in AI systems, and particularly how in AI-human relations, what happens when things go wrong. So who actually owns these issues, and what types of reparations that we can develop between humans and AI systems through services and products. Georgia Gallick is looking at change before behavior. So she's just finished her PhD, and she's looking at AI home assistants and how those assistants can work with us to help reduce pollution in cities. So how we can tackle people's domestic behavior, how we can use persuasion, how we can use concepts from behavior change to trigger new domestic rituals and routines that can help reduce some of those pollutants in cities. And then finally, Marcos Suarez's PhD is looking at symbiotic relationships in environments of change. So he's actually coding through neural networks, generative adversarial networks, and machine vision. And his research is looking at developing a fundamental relationship between design and AIs, and looking at that in terms of symbiosis, so the different types of models of collaboration between biological systems, and then applying that to the relationship between humans and AIs to find out the fundamental state of those AI to human relationships. And then in a different direction, this is some work we've been doing with British Airways. It's called Flights to the Future. We finished this project last year. It's with a range of master students in the RCA. And this is where we were invited to create visions for the next 100 years of flying. We developed a collaboration with NASA, Jet Propulsion Laboratory in Pasadena, Airbus Industries in Germany, Safran in the US West Coast, Foresight Factory, who's an agency who specialize in future forecasting, Autodesk, and Pictureless Productions. At the end of our project, we had a one-month exhibition at Saatchi Gallery in London and Shanghai. And two of the projects here looked at artificial intelligence in the future of flying and cabin experience. So this is a project called Air, and this is a self-packing suitcase. So you lay the material flat onto a table, onto a bed, you put the objects you want to travel with into the center, and then this uses auto-packing features and smart AI-driven algorithms to assemble your objects on the middle of this object, and then to wrap them carefully for you to be able to travel. So it uses AI and generative algorithms. It has gesture transparency, which means you can look inside and see the objects are safe. You can use DNA fingerprinting to lock and unlock the suitcase. And it has smart shape shifting, so it can understand its environment. Say if it's in the back of a taxi, it can morph to fit into shape so it doesn't roll around. If it's an aircraft hold, it can negotiate with other forms, with other suitcases, and whole clusters of suitcases can collaborate to have the optimum forms to take up the least space, and also to stop them moving around as well during flight. So using AI for a future design project aimed for the next kind of 20, 30 years time. Another project called AVI, and this is exploring passenger experience from the perspective of an AI robot. So this is intervening between aircraft cabin crew and passengers and using permissions from social media to understand passengers that maybe are suffering or in distress in the flight, but are maybe very shy or not visibly showing discomfort. That helps the cabin crew have a much more subtle relationship with aircraft passengers, and also to prioritize the attention they're giving to passengers as well. So those are just two examples of some of the work that we've been doing with master students, looking at AI and how we can explore the future of the world, especially through aircraft passengers. So a little bit of thinking now about artificial intelligence and design, and I'd like to read out these two quotes by Norbert Wiener. These machines are helpless by themselves in 1954, and then just last year by Danny Dennett, we are making tools, not colleagues. But I think there's certainly a lot of debate about whether these are just tools and not something more, and challenging us on the intelligence level. And certainly the third law of AI tells us that any system that's simple enough to be understandable will not be complicated enough to behave intelligently, while any system complicated enough to behave intelligently will be too complicated to be understood. So effectively, we're developing technologies that have a level of obscurity. And with obscurity in mind, one of science's key aims is to reduce obscurity about the world around us. I believe that design thinks for obscurity. But essentially, AI is obscure. So the question for us is how to partner with science and design and how to do this effectively for the future of AI. So the essential obscurity of AI, I think design's central value is dealing with the unknown and often the unknowable, and our capacity for both acting and observing systems. And certainly we have an interest in second order cybernetics, in how we can understand different mental models of acting and observing in systems and how that can relate to design activity. So I think we're sort of moving from AI design, I suppose, pretending that we're objective and actually coping with technology impacts, towards designing AI, recognizing the acting observer and developing a comfort with this obscurity. And this is a note of conversation I had with Autodesk a couple of years ago. And in this conversation, they stated that AI will excel in the solution space, liberating designers to focus more on a problem space, which I think is a very kind of fascinating idea about how this can shape design especially, and how it might change the amounts of time that we spend and the effort that we spend in different spheres of design skills and design futures. So tackling one of the original questions we were given, should AI be perceived as object or subject in design? For example, a discussion of AI for design or design for AI perhaps. My view is that if we can never truly understand AI, then we cannot be objective. It must therefore be a subjective object and never an objective subject. We will never gain full understanding and consensus around how AI works and its impact on our world. A cybernetic relationship offers itself as the only useful way forwards, particularly when design is the action and second order cybernetics is the explanation. I quote Ranulph Glanville there. So looking at the future challenges of teaching AI, I think there's several interesting things here. What will be the potential development of AI in 5 to 10 years to come? So will AIs always be noticeable? I think that's an interesting question. If we're educators, at the moment, AIs aren't noticeable. If I use it on my phone, I don't really know whether I'm accessing some AI technology through an app. I'm not quite sure on my phone whether I'm using AI or not. So it's actually quite obscure. We're not quite sure when people are using AIs. And at some point, this is going to challenge our notions of how we educate people and where the intelligences lie. So, will AIs always have a distinct form of intelligence to human beings? So far, we've always made tools and mechanical assistance for the things that we're poor at. So we've tended to avoid duplicating our strengths, and we've used technologies to patch up our weaknesses or our limitations, either through speed or capacity. But that might not always be the same going forwards. So we might have forms of AI that become to be very difficult to distinguish from human beings. And I think we then have to ask, at what point in the future will our students and AI intelligences be inseparable. And that's really important, because how do we know what we're assessing? And what happens when these two collaborations of intelligence merge? How will we know which intelligence is succeeding? Will that actually matter? Do we actually care? Who gains the qualification? This triggers us to ask, is this a co-qualification for humans and AIs collaborating together? And what does this do to our educational system when we're not just assessing human beings, but we're assessing something which actually is a parallel, if a very different form of intelligence? So that brings us to some of the risks and vulnerabilities that we might be facing in the future of design AI education. There's a potential that we might have lifelong financial tie-ins to AI intelligence platforms. What does that do if we want to switch platform? How does that kind of develop our flexibility for learning or working in different environments? There might be shifts and gaps that emerge in the nature of creative learning. So if we do move from this problem space and our technical skills there towards a more solution space shift, which is much more likely to leverage the sort of creative nature of human thinking, that might well change the way we educate. It's also important that we have clarity on who or what we're assessing and in what combination. We've never assessed tools or assistive devices directly, as I've mentioned earlier. So my conclusions: future of designed AI. So we certainly need to revisit concepts of how we act and observe in unknowable systems, and develop a much richer set of understandings in design methods and design research around those areas. Ethics, responsibilities, consequences, and impact for designing in complex systems. Where does the designer's responsibility lie? Where does it finish? And how do we assess and educate complex interactions of multiple collaborative intelligences? It certainly seems to me like we need a new species of designer. So thank you very much for listening.
Okay, thank you, Professor Hall. That's a very interesting talk. Let's see whether we have any questions from the audience. We do have a couple. Professor Hall, what is your opinion about AI influencing or changing human behavior?
I think that's probably a sort of top question of our times, or one of the top questions. I think there's always two different angles to this. The first is that essentially we are still designing, deploying, and developing these technologies. So we have a sort of mode of governance. We govern these systems. So in effect, we still govern how they can impact our behavior. But I think also the understanding of behavioral science, how it links to design, how it links to AI, is still at quite an early stage. So there's lots of unknown impact in that space. So there certainly is the need for a lot more research in that sphere between behavior change, behavioral science, artificial intelligence, design. So it's certainly something that we need to pay attention to. I think the biggest risk is in the complexity of the systems and our ability as human beings to guess or to gauge where those impacts lie further down the line. So we might well develop technologies which look fine for the next 6 months, but in 5 years' time, we realize they've shaped entire behaviors for our populations and things that we didn't necessarily anticipate at the beginning. So that anticipatory aspect of designing for the future is a very important aspect, and something that we certainly haven't fully understood yet, and is going to be one of the major challenges.
Great. The second question is, designers are known for the unique ways to frame problems. What are implications if AI is driving toward a solution-based approach?
Yeah, so I think that's what came up in the quote from Autodesk, which I think is really interesting, and it kind of shows that there's huge amount of data that we're generating. The human beings aren't particularly good at pointing themselves towards that data, so we can consign a lot of that work, potentially to AIs and AI-based systems, machine learning systems, and so that, in effect, that can liberate us. That can give us a lot more time to spend in the problem space, understanding what types of problems we actually want to tackle, understanding what technologies we want to bring towards them as well.
Okay. Thank you, Professor Hall. I think we can move on to our next program, which is the panel discussion.